Good afternoon. Welcome, ladies and gentlemen, colleagues and students. We are delighted to have Professor Liu DiKai from Australia, all the way from, it's a long way fly to here. He is a world expert in robotics, and he is going to tell us his research in this area. Okay, so without any further ado, I will yield the podium to Professor ZHANG Chengqi. He's a chair professor here in the new department of data sciences and artificial intelligence. He, let me also, on the way introduce Professor ZHANG Chengqi. He is also expert in AI. Okay, that's also my field. And he just joined the party about a month ago. Okay, so, right, it's your turn.
Thank you. Welcome, everyone. I think it's my pleasure to introduce my colleague for more than 20 years, the Professor DiKai Liu. And if you read the CV, they have very comprehensive. I try to use my memory to introduce him. He has done research on robotics more than 20 years. He do both theoretical research, application, and the most important, they have developed a number of industry robots applied in the real world. And later on, you can see the video. I accept that, and he also gives a high-level summary about robotics, because we know have so many robotics, so many research, so many applications. He will give our summary. He has authority to do that because he has done this research for so many years, and normally we claim he's maybe it's the #1 for robotics in Australia. And so he not only have a good publications, good applications, he has a lot of media coverage. So later you might see some, and also real application for many areas. And especially he get a lot of award. So from these 3 dimensions, I think he have done brilliant work. So I feel proud of him to introduce him for this seminar. I wish everyone, if you not work in this area, you still feel this hour is worthwhile to come to listen this seminar. Especially you can see the case, lessons, and opportunities, and talk about human-centered intelligent robot. So I give him more time, and people will learn from his talk. Thank you very much. It's your turn.
Thank you very much, Professor Zhang and Professor Zhang and the many professors and friends here. This is really my greatest opportunity to exchange ideas about research on human-centered intelligent robotics. I will be talking about several examples of the robots we developed over the last 20 years, and with the focus on what we have learned and doing robotics research. And then I will talk about opportunities, particularly opportunities collaborations. Over the 60 years of robotics, there are several milestones I like to mention here. In 1959, we saw the first industry robot, and then machine vision into production robots in 1981. And then after that, the first self-driving cars was tested in 1986. And in the same year, Honda started their humanoid robot project. Then cobots, or robots working together with humans, came into the market in 2013. That is the time really start to change the way or the landscape of robotics research. Now, with the advancement of AI and the intelligent robotics, we are seeing more and more robots start to get into our daily environment from home to industry. Industrial robots were designed or have been designed for automation. Then over the last 20 years, because of the advancement of sensing technology and computing, then we start to, or we have been developing in autonomous robots. And the autonomous robots can operate in unstructured environment or in dynamically changing environments. So we have seen many examples. Now, particularly robots empowered with AIs, we start to see humans and robots working together. This could be single person with single robot in collaboration. Or in the future, we are going to see more and more human-robot collaboration with multiple humans working together with multiple robots. So that's what we call the human-robot teaming. When intelligent robots get into our daily environment, one very important aspect is that the robotics research we are going to do, or the robots we're going to develop, needs to be human-centered. So this really introduces or really makes the robotics research as a truly interdisciplinary research area, because humans are one of the main focuses in an intelligent robotics research. And when humans are involved, then we have the human behaviors, psychology, ethics, and the culture. All this should be considered in robotics research. And this is really where we can see more and more collaborations among researchers in all those research fields. So then human-centered intelligent robotics has been becoming more and more popular, or has attracted a lot of attention, not only to researchers, but also to people like engineers and others. We have been seeing videos or news and autonomous cars or humanoid robots. Those autonomous cars or humanoid robots are designed for humans, but they may not take enough human aspects into account. So human-centered intelligent robotics really need to prioritize human needs. So like in the human values or capabilities. So this is one of the significant difference between autonomous robots or human-centered robotics. So this introduced a new philosophy, because humans' experience and also well-being are placed under the forefront. And it's a paradigm shift as well, because technology needs to be aligned with human needs. So it's a new way of thinking or a new angle of thinking here. Human-centered robotics, the design principles, in addition to what we know, for example, functionality or usability, we have to take other functionality or other things into account. For example, usability, employability, and safety and trust. Trust becomes a very important issue between humans and robots or among robots. So UTS robotics research started in 2003. And that was the time we got the ARC, or Australian Research Council Center of Excellence for Autonomous Systems, in partnership with the University of Sydney and the University of New South Wales. That is the time UTS started the robotics research there. Then in 2009, and I initiated the theme or the research program of human-robot collaboration. So that was I've been happy with that initiative. And since then, we have been really doing a lot of research in this topic. And back to 2018, I proposed to establish a robotics institute at UTS. And the reason I proposed that is that I really want to see the shift from purely technological focused research center on robotics to a more interdisciplinary research center, or what we call the institute. So my journey in robotics research started very similar to the journey of the UTS robotics research. So I first started to do robotics research with the focus on field robotics, based robots operating autonomously in the field environment. Then I started working on human-robot collaboration in 2009, and then 21, I started work on human-robot teaming with many people working together with many robots. Here are those, many of the robots my teams, I should say, because several teams, my teams have developed. First, I put them together into the first category is intelligent robots for civil infrastructure, maintenance and the construction. Then the second one is about single person working together with single robot. Third one is about many or multiple humans working together with multiple robots. So I will talk about many of the examples here, which is what I called as a case study. So the first area I like to talk about is about robots developed for civil infrastructure maintenance and construction. So here is one of the robots we developed. You can see this is Sydney Harbour Bridge, which is a quite famous bridge, is a steel structure. Maintaining such bridge is really a big task. So many people working on maintenance of the Harbour Bridge, not only for inspection, but also for removing the rust and old paint and then put the new paint there. And this is one of the operations. For example, use high pressure sand or grit to remove the old paint and the rust. Then after that, put the new coat there. And you can see the working environment. It's very difficult for people to do the work. Then what we started to work on this project, that was back to 2005. Then we worked together with the bridge maintenance.
The robots use sensors and cameras to navigate unfamiliar terrain. The technology is the result of a 6-year collaboration between the University of Technology, Sydney, and the New South Wales state government.
We put the robot into the bridge structure.
It wanted ways to protect workers from lead paint and other hazards.
Then the robot.
The challenge for researchers was to build a machine that could work in such difficult conditions.
Of the surface conditions.
The Harbour Bridge was opened in March 1932. It was an engineering wonder then, and still is today. It's held together by more than 6 million rivets and is a vital cog in Sydney's overstretched transport network.
It's an unknown, very complicated and cluttered environment.
What this project did, or the main focus of this project, is really try to improve humans' health and safety. Because you saw the video, it's very difficult for people to do this kind of tasks. And the productivity or efficiency or cost, those are the focuses as well, but not the primary focus. The primary focus is about health and safety. So with this robot or with this technology, then the robot, as I mentioned, can do the perception, planning, control, and by themselves. And human workers just provide assistance to the operation of the robot, just to do the monitoring and also for quality control. So you can see the difference from purely manual operation to autonomous robots or intelligent robots to do the work. Then the working condition of human workers is really improved. What we have learned from doing this project, that was back many years back. So this was a very challenging problem at that time. And because although we had sensors and we had really good computing systems there, but for a robot to do this kind of task with a comparable performance to human workers, it was very challenging. So what we did is really, so we work together with bridge maintenance workers. That is what we call the co-design or collaborative design. Basically, through this co-design process, we really understand this problem. We understand what human workers think, what they would like to have, what's their priorities. Then we try to develop a robot which can meet their requirements, can address their needs, and also can really value their values. So that is what we learned there. One example was that this robot can do the blasting. Of course, it can do the painting. We just only change the nozzle or the tool and the end is all right. But the workers said this, they are told us that we are very happy to do the painting. You don't have to worry about the painting. So this is a very important piece of message for us. So then we say, that's good. We focus on the tasks human workers do not want to do. And then we leave the tasks they want to do and for them to do what they want to do. So that is a very good example. And by the end, this technology or this robotic system was very well accepted and by the workers. So of course, with their environment, it made our life a lot easier because humans are very good at the perception, right? Can very good at the decision making, particularly handling uncertainties, for example. Then if they want to be involved, then the challenges of developing such a robot will be not as much as we expected. So another case study, which is about the inspection of confined space. For example, in the Harbor Bridge, you can see from the left. So it's confined space. The hole there is very small hole. This bridge was built in 1932. So at that time, people were allowed to get inside to do the inspection, but now not anymore because of the safety concern. So for this case, the inside of this confined space has not been inspected for many, many years. So the only option is going to have a robot there to do the inspection, to do the maintenance. But the challenge here is really rivers are everywhere. The partition plate every 6 to 8 meters, a small hole. How can we have a robot really get into such environment? The
Sydney Harbour Bridge
was
has
a very big challenge.
Then
we developed a robot, just like the caterpillar. So we developed a robot, and which tested many, many times in the Harbour Bridge, and then by the end, delivered to the Harbour Bridge for inspection of confined space.
The Harbour Bridge has her secrets,
here.
A vast
so
network of
the robot you can see,
it's the first
one
time
of the
this
research
section has been
engineers
opened
was
in 5
carrying
years.
the robot on the back.
paintwork dates back to
Then climb the bridge.
1932. This robot
Then
is
put
designed
the
to
robot
get into
through
small
the very
spaces
small hole.
and climb around
After
the
that,
arches,
the robot
checking for
doing the
defects.
inspection fully autonomously. So with this, again, we call this robot as a semi-autonomous robot. And the human workers basically stay outside, not inside the confined space, monitor the operation of the robot, control the quality, and they then provide high-level instruction. That is what we call the supervised autonomy. So basically, human workers provide the high-level instruction or based on humans' knowledge and experience. Then the robot does the hard job or did the hard job. So this is another example. Of course, we have, after the robot inspects the environment, then what if the robot finds, of course there are, what if the robot finds somewhere requires maintenance, for example, to remove the rust or to do the painting, to do the vacuuming, for example, then the climbing robot you saw before does not have the payload or the capability of that payload to do the maintenance of the work. Then we developed another robot, which is this one, like the wall pusher. We'll call it as a wall pusher. So then they can get in with the body to move around, with the arm, 6 degrees of freedom in the front, with the nozzle or the tool to do the maintenance. And you can see the robot can really go through this small hole from one side to the other side and step onto the safe area without rivers. So this is a third example of robots we developed for the maintenance of the confined space or the steel structure. Of course, this technology can be used in many other kind of confined space. For example, the ships or the vessels inside basically so a lot of this kind of confined spaces. So this technology can be used there. And you can see the robot can do the blasting and they can do the vacuuming and also can do the painting as well. So we had so many challenges, not only from research, but also from the development and the practical deployment of such robotics technologies. So first, from research point of view, one of the important or challenges we address is really about the physical capability of robot. So how can a robot can move and support itself in such complex environment? So second one is about intelligence. So what kind of level of autonomy we like the robot to have to do this work? So answer these questions, of course, we did a lot of research. For example, look like this kind of caterpillar and the ants. Like ant is a very good climber. So we look at this kind of biological systems. And by the end, what we found, although we got a lot of knowledge by studying ants or caterpillar or birds or others, but there are a huge number of constraints, or what I call engineering constraints. For example, the weight to torque ratio of motors, or it's very difficult to find that kind of actuation system or actuators that provide very high ratio of torque to weight ratio. So another challenge we had really about the intelligence or the level of intelligence, for example. So if we are going to have a robot in such environment, the robot has to navigate inside the environment, use the sensor to collect as much information as possible. Or I should say, the information needed for the robot to conduct the operation expected. So like the rust around, and also the robot has to move around in the area with a lot of rivers, transfer from one surface to the other surface. So a lot of challenges there. So those are the research challenges we have addressed. And also planning as well. So the robot has to plan its motion based on the environment. And we don't know the environment before. So before the robot reach that area, or the robot do not have this knowledge of the environment. So the robot has to plan this on the fly. So we learned a lot from doing this research. So as I mentioned, besides the research challenges we have been addressing, and there are many others. So I really found human-centered design is really important. So as similar to the example I mentioned before, so we really need to value the humans' preferences and their needs. So that is very important. And also design the interface. For a human worker to monitor the operation of the robot, a user interface is needed. So how can we really design a user interface or interaction interface that human workers will like it? So we had so many workshops working together with the end users. We had researcher who is an expert in industry design, or what we call a collaborative design. And he was one of my research students. So he really in charge of this kind of co-design. So by the end, the user interface was really accepted by the end users. So because they they claim they have the ownership, right? Because their environment into this kind of system or project. Another thing very important is about the roles of human workers and the robot. So how we can really optimize or come up with a satisfactory role distribution between human workers and the robot. So this is another thing we discussed many times with the end users. So again, here, human-centered design is so important. It's really and this is the future as well. One more thing is that you can say 70 times from the lab to the real environment. This is a very big effort. So research or development or deployment, there's a big difference there. So it requires a team with researchers like postdocs, research engineers, really to work together with this, and also with engineers from industry partners. So every time we were so confident in the lab, as we tested many times in the lab with it's very successful. And I asked the team, I said, are you guys confident enough? They said, yes, should be okay. Then the next day they come back and say, sorry, something went wrong. So again, really, this is really the challenge, one of the challenges we have had. But we trained so many people through doing this project. So this is a really important aspect as well. The fourth case study I would like to mention is the underwater robot we developed. So you can see the underwater structure, particularly in Australia, I'm quite sure in Hong Kong, in the Greater Bay Area, is the same. Underwater structure like the bridge piles, wharf piles, underwater pipes, or all this underwater structure is covered by marine growth. We don't know what the condition inside. So in order to do the inspection or condition assessment, we have to remove the marine growth. That is a big ask. In the whole world, divers are still get into the water, use either mechanical tool or use high pressure water jet to remove the marine growth before they can really start to find out the condition and do the assessment. So this is a very big challenge. So you can say how difficult for divers to do this. Particularly if this is along the coastal area, then the water current is a big danger, right? Is a big challenge. So then the only option is really to have a robot there who do the work. So we developed a robot. This is the robot we developed. And the robot consists of 4 grasping arms. And basically the robot navigate above the water, on the water surface or underwater to a bridge structure or bridge pile or underwater structure, then use the arms to engage with the structure or interact with the structure. Then after that, then the robot will use the sensor to build the map or the surface about the surface condition of the underwater structure, identify the marine growth, barnacles, or other types of marine growth. Then based on this information collected, the robot will do the planning, then do the cleaning. You can say this just the robot in the real environment and do the planning and do the blasting, use the high pressure water jet to remove the marine growth. So after the marine growth is removed, then collect information, do the inspection, and do the condition assessment. Of course, robot learning and AI has been applied into this scenario. And you can see here, the main challenge here is really try to address a problem which the current solution is manual operation. And the divers are really tired of doing this kind of work. So health and safety definitely is the main focus. Although we talk about the sustainability of this kind of civil infrastructure. So with this robot in operation, the human workers just only stay in the boat or in the shore then on the shore. Then to monitor the operation of the robot and provide high-level instruction, or again, is what we call supervised autonomy as well. So we have developed many different prototypes. And probably this is the project the team has developed, so probably 4 prototypes from version 1 to version 4. It was very challenging. Challenging because of the application environment, challenging because of the user requirements. And also the underwater environment could be, the visibility could be very low. So how can we solve this problem? Water current could be very strong, or how can we solve the problem? And particularly if there's a water current and they have the robot to interact with the environment, that is challenging. We don't want to damage the robot. So we went through many generations of the design. So many undergraduate students and postgraduate students involved and postdocs as well in this project. So yeah, machine learning, for example, how we can really equip the robot to adapt to a changing environment. That was one of the problems we have been trying to solve. Honestly with you, we have not found a very good solution we are happy with yet. So, but a good thing is that within the last couple of years, AI and machine learning has really been advanced significantly. Then we are having more and more or higher and higher expectation, or we are more confident, basically, yeah. This is the project we'll be working together with Tokyo Electric Power Company in Japan. And they had a big vision to significantly reduce the number of people who have to climb this kind of transmission towers to do the inspection, to remove the marine, to remove the rust, and all the paint, to do the painting, and to fix the problems. So they really want to have a robot which can do the job. So, but you can say how challenging for people doing this, right? But unfortunately, there's no such solution at the moment. And this is the project HEPCO from Japan. They did a global search and try to identify someone who can really work together with them to come up with some technologies to help them to address this problem. So, and we worked together with HEPCO for 5 years. And they went through many ways for this research. So, so this is the first idea we discussed, or we work together with HEPCO. So can we design a legged robot like this? And this robot can really climb up the transmission towers, and then doing the inspection, and also one of the limbs or with the hand will be able to really to do the painting or removing the rust or paint. So challenging, so challenging. After 2.5 years, then TEPCO and us, TEPCO as the end user, we as a research provider, and we discussed with we should change the way to do this. Because the way we realized if we continue to do this, 5 years is not enough to come up with a solution which can really help them to solve the problem. Then by the end, we work together and to develop a robot which can be delivered to a tower. And then this robot will use the sensor to sense the structure, to localize where the structure members are, and to identify the surface condition, to do the planning, and to remove the rust and old paint. But one more issue, which is about the environmental issue. TEPCO in Japan, and they really want to use the blasting technology, mainly because mainly because they really want to protect the environment. So then by the end, we have to work together with them to apply laser cleaning technology to do the work. But again, this was another challenge. So finally, we developed and delivered robots for TEPCO. TEPCO is now deploying this technology for maintaining their transmission towers. So again, the main focus here is the health and the safety of the workers, although we are focused on the sustainability of the energy infrastructure as well. Due to the time, so I probably need to move faster, quicker. I already mentioned some of them, like engineering limitations there, and it's a very challenging problem. How can we really combine the strength of humans with the strength of the robots and the environmental consideration? Due to the COVID, and we were supposed to do a lot of field trials in Tokyo, but because of the challenging period of the time, and we could not do this, then in terms of how or to what level the operators are accepting this robotics technology, we could not do much work on that. So I'm hoping in the future, this is one of the tasks we would like to do together with TEPCO. Okay, one more, another example is that the robots we developed for construction. This is the example for the timber building construction here. And you can see here, we developed a robot which can navigate on the construction site, localize itself, find out where the screws should be placed, and then put the screws into the right places. So this is the project we did with several companies in Australia, and it was very successful. The quality, the efficiency, the accuracy, by the end, what they found, what they means the industry partners, what they found is much better than human workers. So, and now we are further developing this technology for more testing. I will talk about this later. So what we also learned through those case studies is really about the acceptance of human workers. How humans really accept the intelligent robot. So this has been what we have been learning, or issue we have been learning, and has been a topic we have been doing research as well. So, and the different groups of users or workers, they have different expectations. What can we do? How can we really enable the robot to adapt to different user groups? And expectation at the beginning and at the end of the project, always different. So again, this is because at the beginning of the project, they also, oh, I like the robot to do this. Then by the end of the project, also, I hope this robot can do this and that as well. So a good point of this is a very, very positive feedback, right? The good point of this is that this raises many, many new questions for us to address as researchers. And as I said, and also the human-robot relationship. And what is the better way to combine the user strengths or the human worker strengths with the strengths of the robot? So the second topic I would like to say is human-robot collaboration. So here is one example, and a human worker playing with a robot with physical contact and to do tasks in the environment. So this is not trivial. My understanding here is that based on my experience, developing fully autonomous robot or semi-autonomous robot is easier than developing a robot that can really work together with human workers. So, I mean, although we have been saying we like to combine the strengths of human workers with that of the robot, but what is the way to do that? And so we have been trying to answer this question, for example, for this application scenario. And the reason we pick up this as a scenario, because our industry partner was interested in this scenario. You can see how difficult for a human worker to do this. Then we developed a robot which can, the human and the robot really work together with physical contact. And with this robot was tested in the real kind of environment. And what we found by the end of the industry company, our industry partner, took this robot and then they start to deploy it in their business. So what is really important here is really if we can have a robot to physically assist in human worker, not just like socially, right? Socially you can do in a different way, but physical assist, that is really a big challenge. And really, so the perception and for example, the human strengths like perception, decision making, how we can really combine this with the robot. Another example here is that we developed a robot that allows the nurses to very easily to move the robot and they handle patient, for example, from the bed to wheelchair and from wheelchair to other places. From research question point of view, is very similar to the previous examples. So, but this is for different applications. So then with this robot, the nurses can easily move the device around. And also we have many sensors placed on the robot. These sensors will help to monitor the operation or allows the robot to have the operational and the environmental awareness while the robot is used to move or to handle patients. With this robot, the work condition and health and safety of nurses are significantly improved. So this is a very good aspect, similar technology, but for different applications here. And okay. And another example, again, similar technology, but in this case is that we have the robot and with the human worker hold the robot and move around, the robot can figure out what this person wants to do and then do the work. So for example, in this scenario is that the human worker just move the robot to somewhere and tell the robot to say, you are going to install the big screw in that place. So in that case, we do not need the robot really to find out where the screws should be placed and also navigate around, particularly in some areas and a construction site, for example, along the edges or in the environment with very, very limited number of features, which made it very difficult for the robot to localize itself. So if this is the case, then we can have this robot do this. You can say the robot does the hard job and the human worker does the easy job. This is another example mentioned here. Having a human and robot working together is harder than developing a semi-autonomous robot. Many big, really important part is that how can we get a robot to understand the human workers? This is very challenging. We have a challenge to understand our collaborators, right? Even you are shaking hands with your friend. So you get a lot of message while you are sharing hands with your friend, is that right? So, but if you are going to have the robots working together with you to do the real task, then you realize the robot understand you as much as possible, and then significantly reduce your workload. Not only physical workload, mental as well. So, and again, involving with the partners and the users is another issue. Many new research questions. This is where part of the opportunities we have in the future. Because in the future, we have robots really in the work life, in the office, in the industry, or in our home. For example, you have robots in your kitchen or in your whatever you like the robots to do. And you like to tell the robots to do whatever you like to do, right? So with the increase of intelligence of robots, then we can say in the future, this will become a norm, a new norm. And so many questions here. For example, we developed the human models, physical models, like the strengths, for example, right? The limb strengths, and also mental models, right? For example, I'm exhausted right now. I really don't want to do the calculation, like 3 times 3, or we know 3 times 3, but if it is too complicated, right? So that's kind of mental workload. So how really we develop the human models and also computational psychological model, for example. So make the robot to understand that. And also trust modeling. Yes, okay. Trust modeling. So we realize the human trust the robot, and the robot trusts the humans, and the brain-robot interface, and the many other things. So if you are interested, I mean, this really with more opportunities for us to do more research here, particularly interdisciplinary research here. Of course, safety is one of the key challenges when humans and the robots working together. And I mentioned the physical strengths, for example, the arm. And we like the robot to provide the support expected by the user, right? Your expectation could be different from my expectation, right? So we like this. So what kind of support? And those human factors and ergonomics has to be considered as well. And the psychological safety and the mental comfort. So we don't want the robot to really increase the pressure or the stress when we work together with the robot. Many issues there. So that's why I'm working together with psychologists really to handle this kind of issues. Confidence, of course. So how can we really build the confidence? And probably I don't talk about too much here. The human-robot teaming, when many robots working together with many humans. So that is going to be the challenge as well. So then the physical intelligence, cognitive intelligence, and the, oh, sorry, how come this video does not play? I really like to play this video. Sorry. Can I just click the video? All right, okay. Then probably, yeah.
Tiling operations
okay,
started.
so this is the video I like to play. Basically, you can say we have 3 people working together with 3 robots
you want to drop tile.
And 1 robot doing the tiling.
Bringing tile to chosen location.
And then 1 robot interacting with the worker to do the painting. And 1 robot really just doing the installation of the stores or
tile is ready.
Large language model has been implemented in this demo. So basically, that's really helped to for the communication between human workers and the robots.
Hey, Fetchbot. Can you start the painting operation for me?
Affirmative. No worries, mate. Painting operation is now underway. I'll have this wall looking as stunning as the Sydney Opera House at sunset in no time.
And because large language model is implemented here, sometimes we don't have the way to control what the robot responds to the worker. So basically, this is one of the examples here. Due to the time, another scenario here is that, for example, on the construction site in the field, and we can have many robots working together with many people there, and the human worker just tells the robot what to do, then robots doing the work, for example. So as a researcher, we're focused on robotics and AI. But besides this, we have many other things that need to be considered, like the social technical systems, like the computational, like cognitive models, and many other things. Trust. I already mentioned some of them here. Applications. So many applications around. I mean, construction, manufacturing, healthcare, aged care, and plus many, many others. So those are, okay, shows how social technical systems are applied. Recently, we got the Australian Research Council founding a research hub for basically human-robot teaming for sustainable and resilient construction. And we have the themes there, like technology is one of the 4. And technology, people, important theme here, and plus the business and the quality control there. Then we have 14 research programs from technology to people to business. And the outcomes of the research programs will be applied in many different applications, like the road, rail, bridge, transport, and others. So this is a 5-year program. So just start from this year and we'll finish by 2029. Okay, I mentioned this. So, 70 years ago, and the 3 laws was proposed. The first law more talk about the safety of the humans when human and robots working together, right? So robot may not injure a human being, right? That is about safety of the human workers. Second one, which is about human authority. So basically a robot must do what the human workers tells the robot to do. So that is the human authority. Third one is about the robot itself. So the robot should be able to protect itself, particularly when the robot work in a dynamic or unstructured environment, particularly with the human workers. After 70 years, do we have to introduce new laws for human-robot collaboration? So this is a question I guess many of you may have. So I will leave this question for you to think about it. For example, a robot can do whatever it likes, as long as, okay, I need to acknowledge all the collaborators I have hired and over the last 20 years, and thank you so much.
So we have so many people come here, I guess, probably you want to learn more. Not only listen what they want to tell you, also you want to ask questions. What do you want to know? So I think that's more important for people to attend the seminar because you really bring your question to here. We have limited time, and for question, we depend on first person put the hand up, you get the first chance to ask questions. So I give you 1 minute to think about if you want to have a question, and when I said 3, 2, 1, then you have chance to push hand up. You can help me to count who is the first, who is second, who is third, and you will give them number, then they have order to ask a question. But when I organize seminar, all the panel, and normally people feel, why didn't give me enough time? I said, why don't you push hand up soon? So first up, first get question, and we get order to give you chance. Who can ask first, who can ask second, who can ask third. So give you 1 minute to think about, and I will have share you with my idea with this talk, because my area is not robotics. My area is in artificial intelligence. The early time is about expert system, multi-agent, then data mining. And I listened to Prof Liu's talk for a number of times. Sometimes give industry, sometimes give academic, sometimes give general audience. So for my understanding from not in the robotics area, but now not only listen to me, you should think about your question. Then we have called the question, you can put your hand up. So I really like his second or third page talk about, because a lot of people ask, we have so many robots, a lot of kind, how can we classify? And I think the early time, the Prof Liu tell me, in early time for industry automatic, we always call robot. Then Prof Liu classifies that, you see, the robot not move, they fix the place. All of the operations stuff is moving. So that's early time called automatic. And when Prof Liu mentioned all the case, it's a robot move. So he not move the bridge, the robot move. He not move the pipe, robot move. He not move the pipe, and robot move. So he taught me, if a robot move, That's called intelligent. So robots are like human. They should know where they go, how to go, what jobs they should do, how can they do. The robots always move. So they talk about automatic one side, intelligent another side. But actually today, Prof LIU talk a lot of one person, one machine. Because now you talk a lot of robot, either autonomous, automatic, or intelligent. But human robot collaboration. I give several examples. One human, one robot collaborate, help each other. But now he talk about many people, many robots work together for future, for next 5 years. So that's my understanding about robotics. Certainly they have a lot of technology, a lot of issues. If you want to do next 5, 10 years, you still have a lot of research. So now be prepared, put your hand up, you should count. Who is the first, who is second? I don't know who is, you should stand up to see, be prepared to ask questions. If I said 3, 2, 1, then you can start putting your hand up. If you put too earlier, not count. If you put too late, you will rank later. Okay, ready? 3, 2, 1. You need to count who is the first. You need to count. You need to give order. That's first. This second. Who is the third? Hold on. I'm not let you ask yet. You just rank first. This rank second. Anyone want to put your hand up? So if you don't put enough time, you might miss the chance to ask a question. So we already have 2 people want to ask question. So after first question, I give you one more, third, number 3. You need to count, tell them who is 1, 2, 3. So after 2 questions, I give you one more chance. You put a hand, so you have a chance. So now that person can ask first.
Okay, good afternoon, Professor Liu. Thank you very much for bringing us a lot of case study today in the construction field. So my questions may sound a little bit elementary to you, but as a first year in the PhD study, so I would like to ask more about human-robot interaction, this domain area. So you have mentioned for lots of the cases, robots is actually replacing the human role. They are actually designed and built for to do some dangerous tasks, like the hardware cases. They are as a human, they are usually as a role of a supervisor. So they are actually excluded from the interaction. And there's one case, the lady is actually laying the brake with the robot together, very strongly interactive tasks. So my question is, when there are a lot of humanoids coming out, like Optimus from Tesla and like Careboard from Tencent, and I'm questioning, is that as a researcher, is it worth it for us to investigate into the middle of the spectrum between very autonomous type of robot and very manual control robot? I want to hear your comment. Is it the future of the coming trend for us to inject into the middle spectrum of the robot? This is my question. So thank you.
Okay, thank you very much. Very good question here. Robotics is really a broad research field. As I mentioned, it's very the interdisciplinary research topic. So in terms of which topic or where your research will be located in this whole spectrum, from this end to this end, that's purely based on one, your interest, right? You need to find a topic or research task you are really interested. Second is really about your strengths. So whether you are going to, for example, develop like the humanoid robot, right? So you may focus on the really technological aspect, right? To make the robot really very capable, like climbing the stairs or in a very unstructured environment or very complex environment in terms of locomotion or navigation. Of course, you can focus on that aspect. Or you can be more focused on really implementing or developing new models like the multimodal language models or many other different models to increase the intelligence of the robot, to make the robot more intelligent and then can do the tasks by themselves. So you mentioned in the middle, my understanding in the middle means that, so really the robot doesn't matter in the future, after 5, 10, or 15 years, the robot is going to work together with humans. So how much you are going to take into account, or how much, or what kind of human preferences, or human needs, or human values you like to be considered in this research? This is an open question. It's really an open question. So it's very hard to answer your question where you should locate yourself in the whole or very broad spectrum of robotics research. But my general answer here is really find the one you are very keen and you are most interested.
Okay, thank you. Thank you.
Yeah.
Yeah.
Thank you. I think this question is very interesting because I see a lot of young people here. So it's not only, Prof Liu not only do research, also supervise a PhD student, also supervise so many engineers. So you can ask questions not only technical, even you can ask some PhD topic and the career and the relationship between research and the engineer. And you can ask what kind of question, because this is a good opportunity. If not in this time, you say, Prof Liu, I want to send you email, ask a question, probably he's too busy, probably he overlook your email. So this is an opportunity. So after second question, you still have a chance to put hand up, but not now. So now we go to second question.
Okay, thanks for interesting and inspiring talk. To me, there are basically two components into robotics. One is the physical, how you control the control system itself. The other part is the brain, the software, control the real controller. So I want to go into the controller part. So you all know, a couple of days ago, 2 or 3 days ago. So the latest Nobel Prize went to in physiology and medicine went to the two people, Hatfield started a neural network, and Hinton basically, what do we these days call him the deep learning, father of deep learning. So you also mentioned in your research you use a large language model, right? So in one of the interviews, and actually a few interviews Hinton did, people asked him, what about the general intelligence? He basically said, okay, these days, the machine is even smarter than us, already surpassed the human intelligence. It's already with us. Whether or not that's true, that's debatable. So I want to hear your take on this. Do you think we are there? What if we put a very smart brain into the robot you're building? What's the future? Will robot dominate human? Okay, this is not a futuristic kind of question, but I believe if that's true, it will be with us maybe 5, 10 years. That's my prediction, but I want to hear your thoughts. Thank you.
Thank you very much, Professor Zhang. This is an open question for everyone to contribute, I guess. But it's very, 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 it's a question everyone will and should be involved in this discussion. Definitely AI, particularly you have seen from the videos and from the news and this, in the last 2 years, really progressed so significantly. And that is about the control part or the intelligence part. But if this brain intelligence or mental intelligence advanced so much, and if this is going to be combined with the physical intelligence, then definitely it's very, very reasonable to have a big concern, to have a very big concern. Particularly, you can say, combined with the humanoid, with arms, fingers, and they can.
Sorry to interrupt.
Yes.
Do you worry about the Asimov's 3 laws?
To some extent, yes. To some extent, yes. So this really another research area. Probably you have. I did not mention too much, and we have collaborator. We look at the robot ethics And we really need to talk about the regulation. And in the research hub, I mentioned because of the time issue, I did not talk about, we have the regulators involved in the research of developing robots to working together with people. Of course, that research hub is focused on application in construction, but in general, this can be applied in many different industry sectors. So definitely this has been really an issue that needs to be regulated, needs to be widely discussed, and the solutions are needed. The solutions are not technical solutions, or maybe, sorry, could be technical solutions. So yeah, not easy to answer this big question. I guess many of you have better answers than me.
Okay, and anyone want to answer the question because it's an open question. Maybe you can answer if you want, because this is a philosophy question. Everybody can say answer, and hard to say who is yes, who is no, because it's an open question. So, yeah, as I said, we have a third person want to ask question. Is wait for there. Hold on a second, because I would like to see if anyone, if you really want to ask question, use this free chat, and Professor Liu must answer your question. He has no reason to reject you. He can't say he's too busy. He can't say he don't answer. He can't answer. So that's your opportunity to prepare question, and I'll give you 10 seconds. Then I will ask you put hand again. If you don't, and wait for next year, maybe Professor Liu will give another talk. But I wish you can take this opportunity. So I'll give you 10 seconds. Then I will say 3, 2, 1. Then you can put your hand up. Otherwise, no more chance. Okay, 3, 2, 1. Put hand too early. This is number 4. Your number 5, number 6. Probably time is enough. Number 6. Sorry, no more. Number 4, number 5, number 6. Now it's number 3.
Hello, Professor. I think your speech is very inspiring. And as a student of language, maybe I can't ask a very technical question, but as I'm a huge fan of sci-fi movie and novels, so my first question, maybe like the second one, do you think one day the robots will master us, or is there some mechanism that during the design of robots, the engineer will put inside to stop this thing happen? And my second question is, you mentioned that you also work with psychologists in your team. So do the psychologist works to protect the human psychology or the robot psychology, or both? So that's my question.
Well, thank you. In terms of first question, I mean, as we discussed before, yeah, definitely, I do think that is something we really need to working together with the regulators and really with robot ethics people to come up with some ways to manage it. So I'm quite sure people can do this. I'm quite sure, because technology is developed by people, right? So I'm hoping people can do this. So in terms of second question about psychologists, I've been in collaboration with 2 psychologists, and they're more focused on social psychology. Why we like to really work together? They are interested what kind of behavior change when humans and robots working together, human behavior. Human behavior change. So, for example, I imagine like one of the videos we mentioned, we have 3 people working together with 3 robots. And they really want to do experiment with human subjects to find out what kind of changes they can identify. And also they like to build a computational cognitive model. This kind of model can help them about update of the belief or belief update. So the belief could be human belief in robots. For example, how human perceive the robots. Or could it be the other way around, how robots are going to say, human collaborators, what do they think about me, right? So basically in two ways. So the second question we've been trying to answer is really about the dynamics when humans and the robots working together. So look at, they really want to do experiments with subject to find out when humans and robots working together, how the dynamics, like the role changes. Like, for example, in the morning, the human worker may like to play this role, but in the afternoon, the human workers may not want to play the similar role in the morning, for example. And if this is the case, how humans and robots can really work together to achieve this? They still like to build the computational model, but that really requires the experiment with human subjects. So another thing which is really about the decision making. So psychologists are really interested in when humans and the robots working together, how they can really find out from the robot's point of view, how humans make decisions when they work together with the robot. And based on what they can find, then they can really help the planning or control of the robot to make the robot more friendly working together with humans. So those are these topics we're working together with psychologists. Of course, we had many discussions. For example, I asked many psychologists, I said, if you have options to choose robots to work together with you, one is humanoid, one is a robot that does not look at the human at all, and the others could be in the middle. So which is the robot you really don't want to work together with the robot, assuming their intelligence are the same? What is the answer? What do we expect?
Actually, I prefer to work with human, actually, if I can choose. Yes, but yes, I think robot is more efficient and maybe more powerful. But sometimes, do you think robot has emotions or? Well,
robots will have kind of emotional intelligence in the future, not right now. But all the psychologists I have talked to, as I said, for example, different robots, humanoid, looks very like humans, and other robots who really do not like a human, but some other robots in the middle. So the robot they pick up, they really don't want to work together with, is humanoid. Which is real. I mean, I don't have an answer to say why, all right? I don't have the answer, but this is what they told me. They said, I'm a human. I like to be dominant. I like to be in control. It's a good answer, but I mean, probably the preferences are different. Yeah.
Thank you. Our time is very limited, so but actually I like this conversation. Most seminars they have leave 5 to 10 minutes to ask question. You only come here, listen whatever they want to tell you. But for this chance, you can ask them answer what you want to know. So I really like this kind of seminar. But now we have 3 more questions, and I hope each question control in the 2 minutes, plus ask, plus answer. Then otherwise our time is not enough. So number 4 question.
Hello, Professor Liu. Thanks for the brilliant sharing. And my question is actually similar to that lady, but I'd like to ask you a little bit more specific. You mentioned that robots can do whatever as soon as ... right? So you name it, they do it. Because of that, I'd like to know how can we ensure the security for not allowing the robot to be tampered maliciously?
Yeah, it's a good question, which I don't have an answer. Yeah, definitely. You know, there's 3 laws, right? And which were proposed in 1942. And the first law is about, robots should not injure human. Second law is about human has to be in control, right? Human authority. So third law is about really, robots need to protect themselves. So the reason I raised the question, I'm thinking the laws, we're going to have new laws to be introduced. And in terms of what are the new laws we're going to introduce? So I leave that as an open question for everyone to think about it. So, but in general, and as all the questions asked it, so we really say robots should not really, and this cause any physical or psychological or cognitive kind of hurt to human workers.
All right, I think I trust you on that.
Thank you. Now goes number 4. Oh, sorry, number 5. I made a mistake.
Okay, so
be prepared.
Professor Liu, I ask you a question that is related to Hong Kong or nearby area. That we have almost the I don't know, almost it's the first the longest bridge Hong Kong, Macau, and Zhuhai. I think that bridge is very important. I think you develop some robots that can be used maybe for the inspection of the bridge. That is important. I have not seen any robot can be applied. Can you give some ideas about applying your robot in the inspection or something areas in the bridge? Thank you.
Yeah, thank you. And that is a new bridge, and they was number 1, kind of the longest bridge. And the ideally, we don't want. I really say we don't have to maintain it over 100 years or 200 years, if possible. But that is a wish list, right? But in terms of applying intelligent robots for this, I do think there are many opportunities there. So not only outside, but inside, because inside is a confined space, right? And also not above water, could be underwater as well, to look at this. So we may need to change the design of the robot a little bit to accommodate these applications. So, but I do say, as similar as what you are saying, I do see the opportunities there. Yeah.
But I think you need to sell your robot to Chicago. There are so many steel bridge and a lot of bridges rusty. So you need to go to the open market in Chicago. Thank you. Now we have a very limited time. We go to number 6. Last question. Your last person have a chance. Other people have no more chance to ask.
Thank you. Thank you very much. Thank you very much for the presentation. I'm coming from social sciences, and so I would want to ask questions related to this field. I wanted to find out what has been your experience with human acceptance. You did mention that some aspect of human acceptance, but with the fear that robots would automatically, in a way, take over the job of humans. And in your presentation, you did mention that some of the objectives for some of the case studies were to reduce the number of workers in some of the industries. In your co-design, did you have this feeling among the users, the end users, the people who work together, and how did you manage this? And also, I'm thinking that when machines eventually become smarter than humans, maybe human-robot interaction will actually slow down the progress of robots in performing duties. Well, what do you think about this?
Okay, thank you. So from the social science aspect, and particularly involvement of end users in the design of this robot, I do think that is really the right way to go ahead if we're going to developing robots for humans. In terms of how many end users were involved, depend on the applications. For some applications, we have many end users involved, and for some applications, we don't have many, just only probably 3 or 4 of them involved. In terms of how and whether they really by the end they accept it or they liked it or not, my experience here is that the robots we developed, definitely our end users who were involved really liked it because they claim the kind of ownership as well. And also in the design of this robot, we took their preferences and their suggestions into account. So, but if you want to say, if this robot is designed from this group of end user, and if we get other group of end user to be involved and say whether they like it or not. We have not done this research yet. So this could be something you may be interested in, or many people could be interested in the future and to do this. In terms of really robots taking jobs of humans, yes, any automation, that is the case for any automation technology. So the application examples I mentioned here is that it's not about we have enough number of people to do the work. It's more about we don't have enough number of people to do the work. So if we can have one person to work, before we have 3 people working to do one task. Now we can have one person to working together with 3 people to do the job, to do the same job. Yeah, of course, the productivity is improved, but that's still not enough for the applications. So it's not about the application or the requirements are not there. It's more about what we can deliver. Thank you. Yeah.
Thank you. Now I have 4 acknowledgements. First, I would like everyone to thank you, our speaker. He fly to this morning from, yesterday morning from Sydney to here, and this morning come to here and have spent a lot of time to prepare this talk. Even spend an hour, but spend a lot of time. We should appreciate Professor DiKai Liu. Thank you. Second acknowledgement, I would like to share a little bit of news with you because originally received email, we should go to AG204 because so many people is interesting and the room is so small and we can't find the right place. Actually, this place is already occupied by this time. And President Jingguang Teng, or Teng Jingguang, said we need to get this room and ask people to find another place. I don't know where, but I really appreciate President Teng to give us a brilliant room and environment. So I would like to thank for him to give us a good environment for this talk. Thirdly, I really appreciate we have more than 100 people to come to the seminar, and probably not for every seminar, but this one, I appreciate all the audience. So thank for yourself. This third thank you. And lastly, but not finally, is a pair. Spend a lot of energy to organize seminar, and Professor Zhang represents pair. I also want to bring every people to thank a pair to organize a brilliant seminar.
Okay, thanks again for coming. So we have a little gift. It's a souvenir to present to the speaker.